Imagine this. You're floating in space, completely alone, no spaceship, no protection, no rescue, just you, no sound, no air, no sense of direction, up doesn't exist, down doesn't exist, only silence and an endless black void stretching in every direction. Your body drifts, slowly, uncontrollably, and in that moment, a single question hits you. What actually happens next? Do you explode? Do you freeze instantly? Or do you slowly suffocate? And maybe the most important question of all, if space is this hostile, could anything actually keep you alive out there? Because the suits astronauts wear don't just look advanced. They can cost tens or even hundreds of millions of dollars. Which raises a bigger question. What exactly are you paying for? So today, we're breaking down the ultimate survival scenario. Can a human survive space? And what does it really cost to stay alive in a place where life isn't supposed to exist at all? Hashtag Part 1. What really happens in space? Let's start by clearing up one of the biggest myths. You do not explode in space. That idea mostly comes from movies where bodies burst dramatically the moment they're exposed. But real physics doesn't work like that. Space is a vacuum. That means there's no air pressure. Zero. On Earth, you don't notice it, but the atmosphere is constantly pressing against your body. That pressure is part of what keeps everything stable. So when it suddenly disappears, your body reacts. Gases inside your body begin to expand. Air trapped in your lungs, your throat, your sinuses, even gases dissolved in your bloodstream, all start reacting to the sudden drop in pressure. If you tried to hold your breath, your lungs could actually rupture. That's why astronauts are trained to exhale in emergencies. Your skin, however, is strong. Strong enough to keep your body from tearing apart. So no, you don't explode. But you do swell. Your body would begin to expand slightly. Your skin stretching, your face puffing up. Not instantly fatal, but definitely dangerous. And then comes the real threat. Oxygen. The moment you're exposed to space, you stop breathing. No oxygen enters your lungs. No oxygen reaches your blood. No oxygen reaches your brain. You'd stay conscious for about 10 to 15 seconds. That's it. Just a few seconds to realize what's happening, to panic, to try to react, but there's nothing you can do. Then, everything fades. You lose consciousness. After that, your chances of survival drop rapidly. But it doesn't stop there. There's a process called ebullition. At extremely low pressure, liquids inside your body begin to turn into vapor. Not boiling like a pot of water, but forming gas bubbles. Your saliva would start to bubble on your tongue. The moisture on your eyes would begin to evaporate. Even fluids beneath your skin start to react. It's slow, but deeply damaging. Now let's talk about temperature, because space isn't simply cold, it's extreme. In direct sunlight, temperatures can rise above 120 C, hot enough to heat surfaces rapidly. But step into shadow, and temperatures can drop below 150 C. There's no atmosphere to distribute heat, so instead of balance, you get violent extremes, and your body isn't built for either. Then there's radiation. On Earth, we're protected by the atmosphere and magnetic field. In space, that protection disappears. You're exposed to solar radiation and cosmic rays, energy powerful enough to damage cells and DNA. And finally, micrometeoroids. Tiny fragments of rock and metal moving at tens of thousands of kilometers per hour. They're small, often invisible, but at those speeds, even a tiny particle can hit with the force of a bullet. So no, you wouldn't explode. But within seconds, your body begins to fail. You lose consciousness. And without help, you don't come back. Hashtag Part 2, the only way to survive. So how do astronauts survive something like this? With a system called the Extravehicular Mobility Unit, or EMU. And calling it a suit doesn't really do it justice, because it's not just something you wear, it's something you live inside. A better way to think of it is this. It's a personal spacecraft wrapped around the human body. NASA describes it as a fully self-contained life support system, which means everything your body depends on has to be recreated artificially. Inside that suit, it provides oxygen for breathing, pressure to keep your body functioning, temperature regulation to prevent overheating or freezing, electrical power for systems, water for hydration, communication systems to stay connected. It even removes carbon dioxide, the gas your body constantly produces. Every breath you take inside that suit is part of a carefully controlled system. On Earth, you never think about this. The environment handles everything automatically. In space, nothing is automatic. Everything has to be engineered, maintained, controlled. Because if any one part fails, oxygen supply, pressure, temperature, you have seconds. That's the margin for error, seconds. And yet, with this system working correctly, astronauts can step outside their spacecraft, float above Earth, and work in space for 6 to 8 hours at a time, completely dependent on the technology keeping them alive. Hashtag part 3. So, how much does it cost? Now let's get to the question everyone asks. How much does a NASA spacesuit actually cost? The answer sounds simple, but it's not, because it depends on what you include. If you're only talking about manufacturing, the materials, the assembly, then historically, a suit costs around $10 to $20 million. That's where numbers like $12 million come from. And those numbers are real, but they're incomplete because the suit itself is only part of the story. Behind every spacesuit is decades of work, research, testing, failures, redesigns, when you include years, actually decades, of research and development, extensive safety testing under extreme conditions, continuous upgrades as technology improves, maintenance, repairs, and redesigns, and the fact that only a limited number are ever built. The true cost per suit rises dramatically. In modern terms, it can reach tens or even hundreds of millions of dollars. So when you see different numbers online, it's not that one is wrong, they're just measuring different layers of the same system. One measures the object, the other measures everything required to make that object possible. Hashtag part 4, why it's so expensive. To really understand the price, you have to understand what the suit is responsible for. First, life support. The suit must continuously supply oxygen, remove carbon dioxide, maintain stable pressure. That backpack astronauts wear is not just a tank, it's a fully functioning life support system. Compact, precise, and absolutely critical. If it fails, you don't get a warning, you get seconds. Second, temperature control. Space doesn't just get hot or cold, it swings between extremes instantly. So astronauts wear a liquid cooling garment underneath the suit. A network of tiny tubes runs across their body. Water flows through these tubes, absorbing excess heat and carrying it away. Without this system, their body heat alone could become dangerous, even in space. Third, protection. Space is filled with high-speed debris. Micrometeoroids, tiny particles moving faster than bullets. The suit is built with multiple layers, each designed to absorb and reduce impact. Flexible enough to move, but strong enough to protect. Fourth, mobility. Astronauts need precision. They need to grip tools, turn bolts, handle delicate instruments, all while floating in zero gravity. Designing a suit that allows that level of control while still protecting against space is incredibly complex. Every joint, every glove, every movement is engineered carefully. And finally, reliability. Because this might be the most important part. If your phone fails, you restart it. If your car fails, you call for help. But if your spacesuit fails, there is no help, no quick fix, no second chance, just you and the vacuum of space. That level of reliability requires extreme engineering, extreme testing, and near-perfect performance. Hashtag part 5, final thought. So, can a human survive space? No, not even for a minute, without protection. But with the right system, with technology that replaces everything Earth provides, survival becomes possible. That's what a NASA spacesuit really is. Not clothing, not gear, not just equipment, but a lifeline. A fragile barrier between you and an environment that cannot support life. And that's why it can cost millions, or depending on how you measure it, hundreds of millions of dollars. If you want more extreme survival scenarios, from the deepest parts of the ocean to the highest peaks on Earth, to environments humans were never meant to experience, subscribe. Because surviving on Earth is one thing, but surviving beyond it